What if I told you that the entire digital world, your phone, the internet, the very screen you're looking at right now, was built on an equation that its creator never intended? In 1925, a physicist from Austria wrote down an equation so elegant that it reshaped quantum theory almost overnight. It showed that particles aren't just particles. They behave like waves. It all began with a simple question about the weirdness of the universe's tiniest parts. Erwin Schrodinger was trying to solve a crisis in quantum theory regarding the nature of subatomic particles. At the time, physicists were struggling to reconcile the fact that particles, like electrons, didn't obey the laws of classical physics. Electrons broke every major rule of classical physics: Newton's mechanics, Maxwell's electromagnetism, classical energy laws, and the idea that motion and energy are continuous. So he went searching for a new way to describe the quantum world. Schrodinger solved the crisis by giving electrons a new identity. Not tiny particles following Newton's paths, but waves obeying a new equation. Suddenly, atoms made sense. His breakthrough came in late 1925 when he developed the Schrodinger equation, which formulated quantum mechanics as a wave theory, what he called wave mechanics. This provided a mathematical framework for the wave function, describing particles not as points, but as waves of probability that spread out. A wave function is like a magic map that tells you where a particle is most likely to be. A good analogy would be if you looked for a particle like opening a magic box and the wave function suddenly collapses. That is, it shrinks down from a cloud of possibilities so that the particle appears in one spot. The equation he published in 1926 was his attempt to write the master code for the quantum world, a blueprint that would, by accident, build our future. By treating the electron as a wave rather than a solid ball, he created a tool that could predict the behavior of any quantum system. Before Schrodinger, the way the atom was pictured just wasn't adding up. Electrons were imagined as tiny planets orbiting a nucleus, but that model couldn't explain why they acted so strangely. Inspired by the wild idea that particles could also be waves, Schrodinger came up with a groundbreaking wave equation. This equation didn't pinpoint an electron's exact location. Instead, it described a probability wave, basically a cloud of possible places the electron could be. It was a radical concept, but it worked beautifully, accurately calculating the energy levels of electrons and helping him earn a Nobel Prize in Physics in 1933. But the story gets even stranger. In 1935, a famous paper by Albert Einstein, Boris Podolsky, and Nathan Rosen described a deeply unsettling quantum connection. They realized that if two particles interact and then fly apart, measuring one particle instantly tells you something about the other, even if the second particle is miles away, and even if no signal could possibly travel between them. In his response later that year, Schrodinger gave this phenomenon its name: entanglement. This was the idea that two particles could become so linked that their fates were intertwined, no matter how far apart they were, and that measuring one instantly influences the other. Schrodinger said something astonishing. Entanglement is not just a feature of quantum physics, it is the defining feature that marks its entire departure from classical physics. And here's the accidental twist. The Schrodinger equation, created simply to describe how nature behaves at the atomic scale, ended up becoming the master key to the quantum world. A key that unlocked our understanding of electrons in solids, the birth of semiconductor physics, and ultimately the foundational technology of the digital age. And that weird idea of entanglement? It's now one of the core principles, along with superposition and interference, behind the revolutionary field of quantum computing, where linked particles, or qubits, short for quantum bits, promise to solve problems far beyond our current reach. From a pure question of science came an equation that accidentally helped build our digital age and the future of computation. What other scientific accidents do you know of that changed the world? Let us know in the comments. And if you're fascinated by the strange rules that run our universe, make sure you subscribe for more content like this. Erwin Schrodinger wasn't trying to invent the future. He was just trying to make sense of an electron that refused to behave. But his equation became the hidden architecture of the digital age, a reminder that sometimes the most world-changing discoveries are the ones we never saw coming. Until next time, remember, stay curious and keep exploring. Thanks for watching.